The next scenario to cover is adding more sleet or ice pellets. So you have two possibilities there. One is a very warm layer that will fully melt the hydrometeor incoming into the warm layer and then refreeze it in a near surface cold layer. So a couple options there is you can increase your probability of refreeze to sleet and ensure that you will have a maximum wet bulb temperature that is quite warm, over 3.5 to 4 Celsius, so that you're completely liquid. So what we're looking at there is a nice warm layer and then increasing this near surface cold layer. The other methodology for producing ice pellets is to have a warm layer, but only in that 1 to 3 degrees Celsius range. And so it's going to only partially melt coming through the warm layer and then refreeze in the near surface. So you can adjust your wet bulb temperature aloft to warmer or colder temperatures depending on what your scenario is to get more sleet. But you have to be in that hot zone where sleet probabilities are quite high, which is somewhere in the 2 to 3 Celsius range. The other way, maybe you have a larger area of sleet than you had thought, and so you could broaden your maximum wet bulb temperature aloft in that 1 to 3 Celsius range. Just spread it spatially out to create a larger area of sleet. So let's look at one scenario here where we increase the probability of refreeze to sleet. We're going to start into the forecast builder here. And again, we're going to work on the afternoon period, very similar to what we did in the freezing rain scenario. We're going to jump right into the top-down grids and take a look at what those look like. Rezoom our area. So there's the forecast builder window. Just going to move that off to the side. So our maximum wet bulb temperature aloft. Again, a reminder, in the southern area, we just had edited it to somewhere in the 3 to 4 Celsius range down in southwest Wisconsin. So one of the scenarios we could do is put in a probability of refreeze to sleet, depending on what your confidence level is in that warm layer area. Remember that the PoWT only checks the probability of refreeze sleet grid if your warm layer temperature is warm enough. Your warm layer maximum wet bulb temperature aloft grid and temperatures are warm enough to get a full melt on the hydrometeor, which is somewhere over 3 degrees Celsius into the 4 Celsius range. So we can kind of draw it loosely here, and the PoWT code will only look for valid areas where the hydrometeor is assumed to be fully melted. So what we're going to do is we're just going to draw an area down south there, and we're going to assign a 75% probability of refreeze to sleet. Depending on your confidence level, let's say we're fairly confident, so we're going to put a 75% in there. And then we're going to just stretch that out for the afternoon, indicating that there's really no surface-based cold layer change through the afternoon hours. And again, just a reminder with time that those warm layers pretty much stay over southwest Wisconsin and northeast Iowa through the daytime afternoon hours today. So finally, we're going to save off that prob refreeze to sleet grid, go back to our forecast builder window, and hit OK and move on. And take a look at those probabilities and create those. We're going to go for stratiform precipitation and use the defaults for all the other ones, recalculate the probabilities. The snow amount and ice accumulation will automatically update as well to account for more sleet. So now we're going to be taking QPF and we're going to be moving it out of the freezing rain bin and moving it into the snow bin because of snow and sleet being found under the snow amount. So now you see what the change is in the probability of sleet grid. Now have that 75% chance of sleet directly placed into the pot sleet grid. Again, now we'll look at the freezing rain as just the, we take 100 minus that probability of refreeze, so you see the 25s down there. And that would be for temperatures warmer than 3 or 4 Celsius. And so our snow amounts, now you see, have actually increased across the south there to 0.8 to 1.1 inches. That's just based on taking it from freezing rain and ice accumulation and putting it into our sleet grid. Not much change in the pot snow there. So taking a look at the ice accumulation, you can see that the ice accumulation is further south now, and the QPF is only a portion of the QPF it was, because the 25% pot freezing rain has taken only 25% of the QPF that's going into that area for ice, with most of the QPF going into sleet and ice pellet production. So we hit OK. We're moving on to step 5. We're not doing anything with the non-precipitation grids. We hit OK. And we go to our final step in the forecast builder, which is to create the weather type. We're going to hit OK, and it's going to make our weather grids across the southern portion of the area. You'll notice now it's not so clean. It was freezing rain from our last scenario. And notice now by the time we're done with the weather grid, we have a larger area of sleet. We've got actually definite sleet in the southwest portion of Wisconsin with a chance of freezing rain. We're just going to save these grids. So a larger area of sleet forecast because of the probability of refreeze to sleet. So what we're going to do now is make these sleet probabilities just a little bit higher by warming the maximum warm layer aloft a little bit more into the 2 range, 2.5 range. And we'll do the same thing for the late afternoon, and then we'll interpolate those grids. So now we're moving on, step 4, stratiform, remake the probabilities, remake the snow and ice accumulation, and then we'll just do a visual inspection of some of those grids. And now you can see the probability of sleet there is up to 100% because we've warmed the temperatures up there. Likewise, we've decreased the snow probabilities as we get towards 2 Celsius aloft in the wet bulb max aloft. So this scenario is a little bit more convoluted because we do have the refreeze sleet to the south. So you see a little bit of that footprint over southwest Wisconsin. But you also notice how much we've dropped off our snow amounts further to the north in west central Wisconsin. They used to be 5 inches. And we've also increased our sleet in that band through western Wisconsin and into northeast Iowa. And finally, we move on to the final step of the forecast builder to make the weather grid. And there's the final weather grid.